Hello, I am JD and you're listening to The Ongoing. This episode is about a single experiment that changed how we understand where life comes from, how food spoils, and how disease spreads. It reshaped medicine, it reshaped food safety, and it laid the groundwork for vaccines and modern public health. This is the story of Louis Pasteur and the Swan-Neck Flask experiment. By the middle of 19th century, people had been working with fermentation and spoilage for a very long time. They knew how to make wine and beer, how dough could rise, and how milk could turn into something useful or go bad. These processes were familiar. They were managed through experience and tradition. But no one could explain why some transformations were beneficial while others were destructive. Microscopes already existed. Tiny living things had been seen. But many scientists believed in a powerful idea called spontaneous generation. The idea was simple. Life could arise on its own from non-living matter. Maggots appeared on meat. Microbes appeared in broth. So the assumption was life simply emerged. Others argued that tiny microorganisms came from the environment, from dust or air, but there was no decisive experiment that settled the question. That was the situation when Louis Pasteur began his work. Pasteur was trained as a chemist. He was studying fermentation, the process by which substances like sugar are transformed into alcohol or acids. As he studied fermentation, Pasteur noticed something important. Different kinds of fermentation were associated with different kinds of microorganisms. When fermentation went well, the liquid contained one set of microbes, and when it spoiled, it contained another. That observation raised a deeper question. Were microorganisms the result of fermentation and spoilage, or were they the cause? And if they were the cause, where did they come from? If microorganisms truly appeared on their own, then no matter how carefully you prepared a liquid, life should eventually emerge. But if microorganisms came from the environment, then preventing their entry should prevent spoilage. Pasteur decided to test that directly. Pasteur prepared flasks, the kind commonly used in laboratories to hold liquid during experiments. Each flask was filled with nutrient broth. a liquid that could easily support microbial growth. He then boiled the broth to kill any existing microorganisms. So far, this was standard practice. The difference was the shape of the flask. Pasteur used flasks with long, curved necks, shaped like the neck of a swan. Air could still enter the flask, but dust and particles from the air would settle in the curve of the neck instead of reaching the broth. The broth was exposed to air, but it was protected from the contamination. Then Pasteur waited. Nothing happened. The broth stayed clear. No cloudiness, no microbial growth. Days passed, weeks passed, still nothing. Then Pasteur did one more thing. He tilted the flask so the broth touched the trapped dust in the curve of the neck. And within days, the broth turned cloudy. Microorganisms appeared. The only difference was contact with material from the air. From these observations, Pasteur drew a clear chain of reasoning. If life arose spontaneously, then boiling the broth should not have mattered. Microorganisms should eventually appear no matter what. But they did not. If air alone caused growth, then exposure to air should have been enough. But it wasn't. Microorganisms appeared only when particles from air were allowed to reach the broth. That meant the microbes were not created by the liquid. They were introduced from the environment. Pasteur's conclusion was direct. Microorganisms do not arise spontaneously. They come from other microorganisms. Life comes from life. Air by itself did not cause growth. Particles carried living microbes. This single experiment ended spontaneous generation as a scientific explanation. Once this was understood, everything changed. If microbes cause spoilage, they can be controlled. If microbes cause disease, they can be prevented. Pasteur went on to show that gently heating liquids could kill harmful microbes without ruining the food. For example, milk only needs to be heated to about 60 to 70 degrees Celsius to make it safer. This process became known as pasteurization, named after Pasteur himself. It is still used today in milk, juice, wine, beer, and many other foods we rely on. Once microbes were identified as the cause, they could be studied, stopped, or used in fermentation medicine, and industry. Understanding the cause made control possible. The same understanding laid the foundation for germ theory, vaccines, and modern public health. What stays with me about this experiment is how carefully the question was framed. Pasteur didn't argue endlessly. He changed one variable at a time and watched what happened. The experiment didn't shout. It waited. And in waiting, it showed something essential. Understanding often doesn't come from adding complexity. It comes from removing assumptions. And sometimes progress begins not with discovering something new, but with proving that something old simply isn't true. Thanks for listening. I am JT and this is The Ongoing.